All right, I got it set up. We're going. Um, Wait, did Jordan leave? Jordan, Jordan, I swear. Jordan, I swear. Are we chilling here? Oh, we're chilling here.
Are the Git presentations in the tiny cart thingy yet? I don't think so.
They're not in. Oh, you're right. I forgot. I have to move them out of your board. Yeah, we
Do
should.
you want me to do it?
Sure. Just copy them. Don't move them because I'm in the presentation. Anyhow, so I don't know if everyone who's here for last week's. Doesn't matter really if you were or not. Last week we went over like basic Git, just like how to use the tool. This week I'm going to go more over really just open source workflows using GitHub. So it's going to be pretty focused this time. This information should apply to, frankly, pretty much any open source project. It's basically just going to be how do you contribute to an open source project which is hosted on GitHub, since that's essentially all of our projects can be thought of as open source projects. But this should apply to like if you want to contribute back to like the ROS tooling or basically anything. This should be a pretty general guide. So before anything, I should mention what is GitHub in case you haven't used it. I'm assuming most of you have, or at least heard of it. But if you haven't, GitHub is a Git remote hosting service. So fundamentally, it's just host Git remotes. But really, it's a much bigger platform than that. It has a ton of project management tools and is very, very widely used for open source specifically, although some companies like Ford do use it privately as well, which is how the platform makes its money, because it's almost entirely free for open source projects. And GitHub right now is owned by Microsoft, so it's getting a ton of attention in terms of development features and such. So it's just a pretty solid platform overall, which is why we use it. So GitHub in general is divided into repos, which are literally just Git repositories. But because GitHub is a bit more than that, repos are just kind of the organization for things like project issues, that kind of thing. So basically, you can think of each repo as essentially its own software project, which is something that'll become a little more obvious as we work through this. But for example, each repo may be, like in ISC's case, a robot, but also just a single executable, like a tool or a library. Generally, it's not going to be a subcomponent, but like all of one piece of something. So like for example, here is the repo for our previous robot, kiloohm. So you can see kind of in the middle here, this is the actual Git repository, so all the files that are committed. Up here, you can see the Git log. Up on the top is the various project management features that we'll be going over. And down here is the README. If you give a README file in GitHub, it'll just automatically display it for your convenience. And then off on the right is just some like fun statistics. Like you can see, we've pinned a release. It's like a certain commit. We pinned it as this is what we ran at competition. Just an overview of the interface there. So you can clone these repos using the URL from the little code drop down here. Pop it into git clone, and you'll clone it. Something that you'll see if you start using GitHub, nowadays you need to use SSH to get into it. They have a guide on their website. It's not very hard, but just know that you should try and clone using SSH if you have it set up. Because if you don't, you can clone fine, but you can't write to a repository. So it's something that everyone just has to get set up. It's not that bad even on Windows, but just something to be aware of. So one of the biggest features of GitHub for project management is what's called issues, which is conveniently an issue tracker. And so generally what you're going to see these for is both bugs, but also even listing features, like something you're planning on adding, something you would generally track it through here. And as we'll see later, these can be referenced in certain ways. So generally, this is going to be like the source of truth for here's the description of the problem, here's discussion of the problem. It all goes in issues. And I believe, I don't have it here, but this, if you go back here, this just lives up here. So it's very easy to get to. And this is just an example of like issues open on Gazebo. So you see like a couple bugs, but then here's a new feature. They'll just track it here for easy maintainership. So here's an example of an actual issue. I just grabbed a random one from the Gazebo repository. You can see each issue will have a nice title, and then also just a brief description of what the issue is. So just some general guidelines on an issue, because I've seen a lot that are like 2 or 3 words, and it makes me a little sad. Generally, you want an issue that isn't too long. So it is brief, but it should be complete. So like for example, in this issue, you can see they list the environment they had the issue on. So it's in Linux. I think they built it from source. No, they got it from a binary. They didn't build it from source. So okay, we can eliminate an issue already. They describe it and then they give some examples. So it's brief, but it has enough info to work off of. Generally, if you're making an issue, try to include around this much information because it makes it far easier for everyone in the long term. So then, GitHub, to actually fix those issues, GitHub provides pull requests. Pull requests are probably the most important thing to get used to on GitHub because it's pretty unique. But they're essentially a work review system. So what you'll do is you'll write your code, then you'll create a PR asking to merge your code from your fork into their master, and then basically all the code review will take place in this pull request. So you can kind of think of it as like an enhanced Git merge, because if you remember from last time, Git merge, you just take everything from one branch, put into another. In this case, we want to take everything from a branch on our fork into the main repository. But instead of just doing that, we want to make sure it's reviewed first. And so when the PR is done, it will actually do the Git merge under the hood. That works just like normal. This is just like a review stage to make sure it's good before you do that. And so in most projects, including hopefully ours, we're still getting there. PRs are something that you generally use when the project is a little more mature. Changes are important. They can be reviewed easily. If you're doing a lot of rapid changes, especially for like a school project, these are not very useful because you just review them because there's so many. But in a good large mature project, pretty much any change will go through a PR to make sure it's adequately reviewed, and also it provides documentation for the future. Just good processes. And then generally you're going to link PRs to an issue. So generally the process is going to be, I have an issue, I make a PR, you'll link those two just using here's an example that I made a while ago, where I just say closes this issue. Then in either of those two in the GitHub website, you can just jump between the fix and the issue. Just makes things easy. So as I mentioned before, this is a review system, so pretty much any good PR isn't going to get through without a little changes. And so generally, when you submit a PR, the PR should already be in best case, it's all cleaned up, everything's working for you. And so any review it's done is just nitpicking. So then one of the big things with that I'll go over at the end is you should really clean up your Git tree. So commits, there shouldn't be 5 commits that say work in progress, it's not working still, that kind of stuff. You should generally clean up that first. And then generally PRs, you should try and get to only cover one main issue. So don't have a PR that's oh, I fixed the docs and I fixed these 4 separate bugs. Generally they should be targeted. Just open a bunch of PRs. And even if you think about how this would work on the Git side of things, how you would make multiple PRs is to make multiple Git branches and then ask to merge them. And so by making multiple branches, you naturally separate the changes in between them, which reduces the chances of yourself adding bugs to the 5 things you're trying to fix. And it just makes everything nice and separated. Let's say even if one of your issues or one of your fixes doesn't work for someone else, you'll still get to merge in the rest of them. It just speeds up the whole operation. So then something I do want to, I've said this multiple times, but at the end of the day, to make a PR, what you do is create a branch on your fork and ask to merge it into the original repository. That's the only way to do it. Actually, I guess you can merge from one branch onto yourself, but that's pretty much never done. It's almost always from a fork. So at the end of the day, when we say PR, it's just a Git merge, but with a review. Oh, and that's what I was going to say at the end of this. So to actually change a PR, because once you open a PR, it may not be obvious how you can edit it if someone asks for changes, but PRs will actually reflect the changes of the branch on your fork. So if someone says, oh, hey, change this comment is not accurate, what you do is just go on your computer, fix it, push that commit you made to your fork, and then it'll automatically update the pull request. Everyone can see your issues, everything like that. So it's pretty simple. So then I guess I should, oh yeah, it's true. I haven't mentioned what a fork is yet. That's kind of important. So I keep reading forks aren't actually a Git feature, but on GitHub, they're just kind of a given. They're used widely. So what a fork is an exact clone of somebody else's repository under your account. So basically, let's say I had to do this. I forked Gazebo. This is Gazebo here. You can see it says forked from, that's mine. At the top of every GitHub repository, there's just a fork button. You just click it, and it just makes it. It's pretty nice. And And what this is used for is making changes to submit back. So basically, if I see a change, I'd fork it, and then I would do any work that I'm like, just anything work in progress would stay in my fork, and it wouldn't be polluting their repository. So if you think like, say something like Linux, like a massive international project, for everyone to have an individual branch on that repository would be absolutely insane. It would be literally millions. So what you do is you make a fork of it instead, do all your work, and then that's why PRs exist, to merge it back in. So like I said, this is just kind of a given on GitHub. You'll see it referenced a ton. That's just the way you make changes. And I should note, when you fork, Git will show two remotes in your thing. One will be called origin, one will be called upstream. Upstream is the repository you forked from. Origin is your copy of it. So when you're doing pull push, you can reference those accordingly, and it's just nice and convenient. You could set this up manually, but GitHub makes it very, very easy. I think this is pretty much what I just said. Oh yeah, so one of the big gotchas with a fork here is if someone else pushes to, like, let's say I have, there's like Gazebo master and my forks master. If they push to their master, now mine's out of date. And if I'm doing my work on the master branch, before I create a PR, I have to merge their stuff in. Because if I don't, then it's going to require them to rewrite their entire Git history to merge my PR, which nobody's ever going to do, because that's obviously terrible. So what you're going to want to do, I have some details at the bottom of the slide. But essentially, you should try and do a fast forward merge, or a rebase, whatever you want to call it, from the branch you're targeting on their end to the branch you're working on. And if there aren't any conflicts, that'll update all of your code to look exactly the same as theirs. Because if you do a three-way commit or a manual merge with a three-way commit, it'll add an extra commit, which will then break the history even more. So generally, this is something you'll learn a lot if you're working with GitHub. It's often easiest just to delete everything and just resync. That's the thing at the bottom there, the git reset hard, upstream, branch name, generally it's master, whatever you're working on. That'll delete all of your local changes and update it to theirs. So that's just something that generally I'll do before, like let's say I had a fork, I haven't worked on it in a while, and I just want to get it up to date, and I know I'll do the changes today, so I'm not worried about them changing anything. I'll just do this, get it all up to date, and then to get it actually on GitHub, it'll scream at you if you do git push, because it's just a lot of conflicts everywhere. You can do git push tac or like hyphen force, and that'll just completely obliterate the remote's git history to yours. You should never use git force outside of the scenario, because you can just destroy everyone. You can just arbitrarily delete git history, which is bad. That defeats the point of git. But this is like the one acceptable use case for it. So this is something that you'll see. You'll learn this pretty fast if you work with GitHub enough, because you'll run into it a lot. So then here is pretty much everything I talked about, but hopefully it should be a little more obvious once I put it a little graphically. Essentially, the order of like I mentioned, open source like workflows, what you'd use GitHub for, pretty much everything is right here. So generally, if you're using someone else's software, like even the clubs, you'll notice an issue, and you're like, oh shoot, there's an issue. I should let other people know. So the first thing you would do, go to the Issues tab, create an issue with the descriptive guidelines I gave you before. Hopefully that gets noticed. Maybe there's some conversation back and forth of, maybe we've seen this before, maybe it's just an issue on your end and we don't need to look into it. If not, though, either A, someone will look at it, or realistically it's open source. You have to do it yourself, unfortunately. So then you're like, okay, I gotta code it myself. What you'll do, make a fork of it. You'll do all of your work in progress code on your fork, because that won't affect their repository at all. But your code will still be on GitHub. So like I code on both my laptop and my desktop, I would be able to sync between those two without manually copying stuff. Just, still using Git, very convenient. And then once you've written it, tested it, documented it, like it's all done, it's ready to be in production code effectively. You open your PR. And then already I've kind of gone over those guidelines, but it should be, you should treat it like, especially like for instance, all of these on the slide are based off a commit I made to fix a bug in Gazebo. Gazebo is genuinely used, like it's actually essentially a production tool. See, for something like this, you should really make sure that your code is very well tested, very well documented, because it will be used by potentially thousands of people. You should make sure it's up to snuff. So then, as mentioned before, your PR will be reviewed. Again, I know mine was absolutely demolished in review. That's just something you have to get used to, because chances are you're going to do something wrong. There's going to be some weird style guideline they want. But hopefully once you get, go through all those, gets reviewed, you get the good LGTM looks good to me, it gets merged, and then that'll do the actual git merge. Your changes will be in master, and everything will be good. So I don't know if I had, yeah, I do have a demo. So we have a ISC Git like repository you can mess with. I'll get into that in a second. However, Brett here submitted a PR the other day for the website, so I'm gonna actually merge that as a little like demonstration of everything we've done, since it is literally club work. All right, so then, as you mentioned, this just logged into my account. Here's just the GitHub home screen. All of these here listed are just repositories. So, for example, here is the ISC GitHub organization. So all of our software is hosted under this. So you can see, like, here's our snowplow, here's Ohm, here's like components of Ohm and just various drivers we've written. Now, first here is our website. I don't know if you've seen it before, but we have a website. It's a cute little thing. Come on, website. There you go. It's a little website. Brett noticed a bug. What's the bug? Is it current projects or current projects? Yeah, that happens. So if you click on current projects while you're on current projects at 404s, so I told him, okay, you're a developer, fix it. And so he did. Like I mentioned, the ordering, saw an issue. If we go to issues here, error 404. Here's this beautiful description of the issues, just describes what we just seen. Now if you'll see, he's linked a PR, so I can go over to his PR. It says it closes the issue describes all the, the problems. And you can see here's the actual commit. So here's the actual changes, so I can go through and review this. But before this, you can notice this. Brett Chody wants to merge one commit from ISC main from Brett Chody main. You can see Brett Chody main is his fork. So here's the fork that I mentioned earlier. You can see it's one commit ahead. So all his work is here. He wants to merge this master branch with one commit over here. And you can see if this was your repo, or apparently if it's not your repo, I didn't know you could do this, it'll have this little bar here. If you click this contribute, open pull request, this is how you would open the pull request in the first place. It'll generate all the info for you. Very useful. I don't know why you can merge other people's code into other people's code. That's kind of weird, but whatever. So anyways, I can go over here and see. So I haven't actually looked at the code. So here's some live code review, Brett. I hope it's good. How many lines changed? I think I was gonna say not many. All right, so it changes the class href to class, href to class. Normally, I would go through. Hopefully it's actual code review. I'll actually test his code. Here, I've already seen it works, and I'm not going to go through the process of manually testing this website. So what it'll do, Sonar Cloud does say it has 0 bugs, 0 vulnerabilities, 0 code smells, and 0 security hotspots. So clearly it's perfect. So as a reviewer, most people won't see this, but I maintain the repository, so I'm the one taking in these requests. I'd be like, all right, it looks good. So I'm gonna hit him with the looks good to me, one hand. And then here, this is something that, oh, that's hilarious. They set it up so you can only squash. Okay. Previous IC set this up. So when you're actually merging the commit, you have the same options as command line git. And this actually matters a surprising lot if you want to keep the repository clean. So basically, there's 3 ways to merge it. You can create a 3-way merge commit like you would on the command line, and that'll, in the GitHub history, list all of the commits and list the 3-way commit. You can do squash and merge, which a lot of people prefer, presumably the old ISC people as well, because that's the only one they allow. And what squash and merge will do is take all of your commits, smash it into one commit, and do that single commit. And a lot of repositories like this because, again, think of Linux, but I think it has 3 million commits. If they allowed every single commit in every PR, it would be like literally almost a billion or something absurd like that. So it just keeps it clean. You can look down. see it in the future. And then rebase merge is essentially the same as merge commit. It just doesn't create a merge commit. But most repositories will use squash and merge. I've used it most of my time here. From what I remember, I believe it's what Gazebo uses as well, and thus most of ROS, I would imagine. So generally, that's what will be used. But anyways, if this is a repository you own, you have the ability to do this. So it's all good. So I'll just squash and merge. And then this is the actual commit that's being made. Generally, the commits will have the name of the issue and importantly link to the issue, which means if, let's say, this doesn't actually fix it, we can see what was reviewed, see what went wrong, and hopefully reverse stuff. So generally, I would just leave it like this. Then just confirm. It'll go. Oops. Okay, well, I should have posted this first, but that's fine. Give them a little heads up. You can see it merged. And now one of the cool things is because we've linked the issue here, it should close the, yeah. So it automatically closes the issue, just makes it nice on your side. Again, if you think about a large project, even if let's say all of us are working on the same project in here, you can imagine manually looking through every issue and making sure you close the right one, kind of a pain. So it deals with that for you, which is very convenient. And then if you'll see on master, there's the commit earlier. So this is the last commit that was up. So because we chose squash, you can see it just made one commit. And if we click on it, actually there's only one commit in the PR too, so it doesn't list it. Normally, if you do a squash commit, it'll list in bullet points the names of the other commits so you don't lose that information. But you can see, importantly, it links back to the PR. So if this doesn't work, we can go back to the PR, see who reviewed it, see what was done, when it was done, etc. Good project management stuff. And then really that's pretty much the entire pipeline. One thing I didn't mention in this that I should is continuous integration, which is kind of its own entire topic in like IT computer science. But essentially the idea is that platforms like GitHub have the ability to run things automatically on your code to detect issues. And so the idea is that you continually integrate this testing into your development so that every time you commit, you correct errors early before it shows up in production. It's something that I believe like the software engineering classes hit on a little, and that's pretty widely used today. So for example, I failed, that's kind of funny. You'll see GitHub has its own little platform. When you're using it, it'll show up with these little dots. That's the code running on their server. It's just like a Linux script, basically. It'll error if there's an issue, won't error if there isn't an issue. Generally, you'll do things like run your unit integration tests here. In this case, it's linting for like code smells or just like generally malformed code, that kind of thing. That's something you'll see a lot. You don't have to worry about it too much as a user, but we're hopefully applying that to our ISC code bases just so we don't have to be like, oh, hey, please don't comment like this. It's really ugly or something. It'll just do it for you, hopefully. That's just something to be aware of. And a lot of repositories, I know, Gazebo included, will actually refuse to merge unless the automatic checks pass, which is also convenient. So like Gazebo required me to write a unit test to prove that my fix worked. And so that actually wasn't passing at first because of some weird bug I had. And so they refused to merge. Like I couldn't even request to merge until I got that working, which is, again, something you'll see in a few projects. But yeah, that should be pretty much it. I'll say other stuff here. Oh, right, this. So I know I went through this pretty quick, but we do actually have a repository on our GitHub organization that was made forever ago for learning all this. So I believe on it has instructions in the README on just like how to create, basically everything we did. Create an issue, create a fork, create a pull request. At the end of this presentation, I have a few more slides to go over on just some Git tips. I'll have a QR code to this. I would highly recommend just going through it, doing the issue, creating a fork, creating a pull request, just to get used to it. So if you ever have to do it in a project, you're not caught trying to learn GitHub instead of just doing your code. All right, so then going forward here, I just have a few slides on just some Git tips that helps with cleaning up your code, because this is something that I found myself Googling for a bunch, and so I thought it'd be useful to mention. A lot of these you do kind of still have to go the old copy paste from Stack Overflow, just because the commands can get pretty esoteric pretty quickly, but at least you don't know what to Google for. So first, easy one, Git messages. I didn't know this for a while, but you can actually make arbitrarily sized Git messages. Like you can put entire essays in these things and it doesn't matter. So like here's a commit on Firefox. You can see the Firefox dude just explains the entire problem verbosely. This is a good thing, especially for complex issues. I think on OMA I have a few commits like this that just explain all of our issues and why we fixed it. So if you have the same problem in the future, you can look back and see it. Don't always make these essays. They don't need to be. But if you have a complex issue, I would highly recommend making this as descriptive as possible because ultimately, really, it adds no overhead in the future because it just adds a little ellipses you click to expand. So it's pretty much no downside to something I would recommend doing. So then probably the most useful Git feature I wasn't aware of at first, but also probably the most advanced to Git feature period is the interactive rebase. I should mention what a rebase is. A rebase is just, I mentioned fast forward merges last meeting. A rebase is just another word for that. It's just kind of just a terminology. An interactive rebase is a confusing name, but basically what it lets you do is go back in your Git history and just arbitrarily change commits, which is extraordinarily useful. It's actually something we had to do on Brett's PR because, for example, probably the biggest use case for this is, I mentioned earlier, you really shouldn't have like 12 commits that just say, work in progress. It's not working. Oops. You really shouldn't commit those. So how do you get rid of those? And of course, you don't want to just redo all your changes manually. That's terrible. So what you can do is run an interactive rebase. And what that does is you give it a commit to start at. So let's say you want to redo the last 5 commits. You'd say go 5 commits ago, or it'd be like head tilde 5, I believe, would be 5 commits ago. And then it'll one by one give you the option to do pretty much anything to those. So like the classic one is to like rename or squash 2 commits together or drop a commit entirely. I'll show those in a second. But this lets you just in mass solve issues like that. And this is something I'd mention in the PR, but I would really recommend running this pretty much every time you do PR because everything can use a rename. There's always like, oh, I forgot 1 semicolon. I have a commit with 1 semicolon. You can merge that into another one. Just keeps things clean. And this is hard. This will blow up your repository multiple times. Make sure you have this backed up before you do this. It's Git, so you can just push to master and then blow up your local and just reset if you break it. Because you can actually run just arbitrary Linux commands on each of these commits if you want. So you can find some Stack Overflow posts with just ridiculous things that solve issues. It's one of those things where, again, if you have a very specific issue you need to solve for commits, just Google it with interactive rebase and you'll probably find one that works. So here, yeah.
I have a fun question then.
Yes.
So what would a Git Rebase Origin Master do?
Rebase Origin Master. Would that rebase everything on master to your local?
It just rebases it to direct, like just to master. The current state of master is now your base.
Yeah.
So a living hell for any large project.
Thank you, Josh. Anyhow, this what you've been seeing here. This is a rebase. It looks terrible. One of the things I should mention, I've been like, oh, choose what you want to do. You probably know this. It's a command line tool. I don't know why it does this. It's kind of neat. What it'll do is create a new file in your native text editor. So on Linux, it'll open it on either Vim or Nano. On macOS, it just opens it in the text editor, which is kind of funny. In Windows, I think it opens Notepad. I'm not actually sure. It just opens, actually, when you install Git on Windows, it asks you, like, what is the default text editor? That's why you want to change that, because it's Vim by default, which is pain. So what it'll do is open a file with the name commit edit message. And then what you can see, it's too fast. When it lists out those 3 commits here, that's when you choose what to do to them. So like here it says pick. He changes it to reword. So he's rewording that 1 commit. You save the file, and now this is actually rewording that commit. So it'll just do by commit, open new files in your text editor, you do your changes, save the file in the text editor, and then Git will apply the change. So it's kind of weird. Honestly, if you have something like VS Code or Visual Studio or like CLine or something, I'd highly recommend doing this in IDE because all of them have way better tools for doing this than the command line. But if you do it on the command line, this is what it looks like. And yeah, and then you can find like the pick or reword. There's terms for basically anything. Git's website, which I mentioned last week, has documentation on what all of those do. I'd highly recommend just referencing that whenever you do something because it's far too many to commit to memory, to be honest. But yeah, and this is something that, again, like most of this, I'd recommend just do a practice PR, get used to this. because it just takes a few times and you'll get used to it. And so then the last thing, some repositories, and we're not requiring it here, but it's just nice to do, require you to quote sign off a commit. So if you think of like signing off an email, you put like your name at the end, your email address, your titles. You can do that on Git too, actually. So if you commit with tac lowercase s, what you'll do is, you can kind of see it in the bottom right. Maybe it's kind of small, but it shows signed off by the name, the email, reviewed by, signed off by. Just adding this tac s, whoever did work for this commit or PR on GitHub will be added to the sign-offs. And so while on GitHub this seems pretty useless because you can just click on their username and see who they are, off of GitHub, Git has no accounts. You just have the name you put, which can be completely arbitrary. So this is very useful if you're not on GitHub, just on your local PC trying to figure out who worked on a commit. You can look at who signed off on it, and then that's another way to do it. So this is just something I'd recommend doing. It literally, there's no downside. You just put tac s and it just does it. And that can add it. I believe you can actually configure it to do it on every commit. But you'll also see some projects. I know Gazebo did this because of the aforementioned. You need to see who worked on what. Some projects will require you to put this here. So it's just, honestly, just kind of a nice thing to make a habit out of, since you just won't run into an issue. All right, so that's the end of my Git tips. This is the URL to the repository at that URL. Actually, it's a QR code to that URL, not right. Anyways, please do this. It'll, like I said, there's a guide that reiterates a lot of what I did, and actually some other stuff because it was just like the last generation of ISC's presentation for this. So that reiterates on a lot of the stuff, has a little to-do list. I'd recommend going through it. Shouldn't honestly take that long. But then you can get added to the increasing list of commits on the repository as well, which is cute. And that should give you a pretty good intuition for doing this in the future. And yeah, should be it. Is there any questions? No? Good? Cool. So if you guys do this, I'll try and pop in and review some of the PRs, maybe merge them, that kind of thing, as you put them in. So expect that. That should be all.